I'll move to neural networks, and we can finally ask some questions, and we will share the notebooks with you. Okay, so neural networks for regression. Okay, neural networks are like fancy ways to model data. We can do nonlinear regressions, and we can do these quickly lines with neural networks. So basically, this is inspired by biological neural networks that appear in brain. I got these two pictures. This is a biological neural networks, and like similar to that, we have our neural networks that we use in computer science. So we have our input layer. This is similar to what we have here. And then as our hidden layers, we have, instead of axons, we have our hidden layers, and then we have the output layer that finally gives the output. So these are the three main layers in neural networks. And in neural networks, we basically fit, we input our data and we estimate these weights and bias values. And we use a technique called backpropagation to do that. We will share all the links that you can look into. So we won't go into detail, and we will just go into the code. So what happens here is you have something called activation functions in this hidden layer, and using these weights and biases, you change these activation functions. You basically change the lines, and you can get these quickly lines to fit the data. So I'll move to our Colab notebook, and we'll see how we can use the MLP regressor. So from a scalar neural network, we get the MLP regressor, and we fit the data. So for MLP regressor, you can have these hidden layer sizes, and you can give the activation function you use, then different learning rates. So this is a bit too much to teach within a short time. So we will share links with you for more information. So here I have used the hidden layer sizes of, let's use 2 and 5. And we use the activation function redo and learning rate as 10 to the power minus 5 and random state as 42. So you can repeat. So then we fit on our training data, X train and Y train. We call the fit function. Okay, so now we fit it and we make the prediction similar to what we did earlier. So nn.predict, we use the test set and we make our predictions. So let's visualize what it looks like. Okay, so this doesn't really look nice like what we saw earlier. And to be clear, let's look at the RMSE. So it's 9.51. Previously from our regression trees and the simple linear regression, we got 2 points something. But you know, this is a fancy way, but you must be wondering why we still have this high root mean square error. So you can change it to different values and you can play around with it to get an optimal value, to get a nice value. So let's just put 10 and 100 and let's fit it again. So now I change the hidden number of hidden layers to 10, and in one hidden layer there are 100 hidden units, and the activation function is still the same, and I'll fit the data. Okay, so now if we do the prediction, okay, now it's much better, right? So we have the straight line we want, and the evaluation measures is 2.08. It's much better than what we got earlier. Okay, so now we talked about 3 methods that we can use for general regression. Okay, I think there's a question in the chat. Can we use any methods to improve our evaluation metrics? Yes, so yes, you can use different methods to improve your evaluation matrix. So basically these are three models that you can use, or there are many things that you can do. You can change the parameters, you can do some parameter tuning, and you can change the scale of the data. So by different methods, you can play around with your data and improve your evaluation measures. So what we actually need at the end of the day is to have a good good um, testing accuracy, or in this case, testing root mean square error. So you can play around and do try different things to improve your models. Yes. Okay, so right. So all this time I was showing you about regression methods, but as you saw, we had a data variable, and we really ignored what this data